And you cannot find the point using substitution. But I hate when people have to do graph, especially after the 80th graph.
I'll just pass this attendance sheet around, so just put a tick beside your name there. Questions? Okie dokie. Okay, we're going to start the next lesson in a moment now. So many people help with this. So I'm just going to do it again in the tutorial this week. So I'll do some more examples on the Thursday class. So what you can do is you can skip this to the start of 2. Okay? Yeah. I'm not so worried about this for the exam, because in the exam they ask for these two. Yeah, I would get the x and the y intersect and draw the line. And then try to read this point. Yeah, so for your homework, just estimate. So for example, if that's 8, I'd say that's 6. And what's that number? My number is 7. So maybe that's 1. Maybe 6, 1. What number is this? I mean 1, 6. What number is this one? 1, 2.
What is mine?
I think that is supposed to be 1, 2.
No.
That graph's a little bit off. Anyway, yeah, in the exam you would use graph paper, so I'm not concerned about this. You're doing it the right way. Although I kind of would prefer it for math off, yeah. Did someone else have a question? Oh. Yes, I write it down, so it's 9/7. What's that? 1.28. 1.28? Yeah. So, if it's 1.28, then maybe you want to go over the quarters, like 0.25, 0.75, 1.25, just mark it then off of that. That's what I would do then. Yeah. Oh, sorry. What method is this? Elimination? Yeah. You multiply this by 5? 15, 20, 25, and minus 9? Minus 4. So that's minus 8, minus 20, and minus 4. And you add them. Yeah. So that's 7. But that's minus 9, isn't it? So when you so minus 4. Yeah. So when you add 25 and minus 4, what do you get? Sure. 25. That's the problem. Yeah. Yes. So many people are. So I'm going to do this one tutorial. It's kind of easy to do them with graph paper. So for homework, I'm not so fussy about accuracy. You can just try your best. I'll do more than the tutorial. I might need more practice using graph paper then. Yeah, when you did it on the graph, what did you get? How close to 1, 2 was it? Okay, I will do it on in the tutorial. We'll see how well I can get it. Yeah. Yeah, no problem. And in the exam as well. Okay, let's continue now.
Okay, can we look up, please? Can we look up? So we're going to start the next lesson now. So what's this now? We've had 3 lessons, and in the 3 lessons so far, we've looked at linear equations. So previously, in maths class, we were doing y equals mx plus c, and these are linear equations. And now we're going to move on to quadratics. So what exactly is a quadratic equation? Well, that's one that looks like this. Ax squared, bx plus c equals 0. That's a quadratic equation. There's only one proviso. This is a quadratic as long as the a is not 0. Because if the a was 0, it'd be a linear. It wouldn't be quadratic. So my only requirement for this to be quadratic is that the a is not 0. The b and the c could be 0, it's just the a can't be 0. Alright. So a little bit of vocabulary now. Okay. So suppose I have something like this. X plus 1 times x plus 2. So if I multiply this out, the usual order of operation is first by first, so that's x squared, first by second, so that's 2x, second by first, x, and second by second, 2. So I end up with x squared plus 3x plus 2. What is the verb that describes going from here to here? No, not quite. Yeah, this one here is expand. What is the verb that describes going from here back to this? That one is factorize. So just be careful with those two. Expand is multiplying and factorizing is going backward. And what we're going to look at in this lesson is how can we go from here back to the original. Okay, so you can see here a quadratic equals a linear multiplied by a linear. And we want to learn how can I go from quadratic to its original linear multiply linear. By the way, these guys here, they have a name. I'm sure people know their name. What are they called? What are they called? Yeah, factors. Or linear factors. Okay, so just write this a little bit down and then we'll have a look at how to factorize. Okay, have we got that? So, I'll just scroll down a little bit to here. So I'm going to take this one as an example. The example I'll start with is x squared plus 3x plus 2. And the reason I'm starting with this is because we know the answer. The answer is x plus 1, x plus 2. So this is how we factorize something simple like this. We know the answer has 2 factors. And we know that this must be an x and this must be an x. And what we need to think about is this. I need to think of two numbers that multiply to make 2, yeah? And they add to make 3. Well, it can only be 1 and 2. Plus 1 and plus 2. 1 multiply 2 makes 2. And 1 add 2 makes 3. Okay, so the idea is you want to figure out two numbers that add to make that and that multiply to make the back number. So let's have a look at another example. Get the idea. Let's say x squared plus 6x plus 9. Okay. I need two numbers that multiply to make 9 and they add to make 6. Well, it has to be 3 and 3. 3 multiply 3 makes the 9. 3 and 3 make the 6. Okay, well, so that's easy enough. So let's make it a little bit harder now. Yeah.
Can I use the calculator instead, or I have to show you steps?
No, if you can use the calculator to get from here to here. Yeah, but the problem is when there's numbers here. You know. You can? Yeah. You can. If you're confident enough that you know how to make it look like you factorized it in the exam, that's fine. Yeah, but there's no workings to show for this.
And then you just when you get the answers on the calculator, you just put it back into
Yeah. But you'd be surprised by how many people screw it up. So their calculator says x is 2, so they write down x plus 2. Yeah, I know that, and you know that, but in the exam you'll forget that, because in the exam you'll do stupid things. So yes, you can use the calculator if you know how to do this on your calculator. No problem. But you'll shock yourself by some of the things you'll do in the exam. Really. I've seen some amazing things done in the exam. Anyways, it's think of it like a newspaper Sudoku puzzle. Something you'd have to think about for a few minutes. It's mental exercise. Okay, let's look at one that's a little bit harder. X squared minus 2x minus 8. Now the reason this one is harder is because of the minus. So we need two numbers that multiply to make minus 8. So the only possible way I could multiply to make minus 8 is if one of them's a plus and one of them's a minus. Yeah, and they have to add to make minus 2, so it has to be 4 here and 2 here. Yeah, because minus 4 and plus 2 makes the minus 2 then. Okay, let's have a look at another one here. Now we get more interesting. Now this one gets much more interesting because we have the 10 in the front. Now this changes how we have to figure it out, so please watch carefully. Yeah, at least. Now, when you have a number in the front like here, we have a number here, a number here, number here, and a number here. And listen carefully, the way it works is like this. These front two numbers, those front two numbers must multiply to get what? Does anyone know? The 10. Okay? And the back two numbers multiply to get the 6. But then, what you need to do is multiply these and add them to the multiplication of these two. So, front by front must equal 10, and the back number by the back number must equal 6, and then what I call the inner plus the outer must equal 17. Now there's so many combinations here. So for example, you might be thinking, okay, well 10 could be 5 and 2, let's just say for example, and what could be 6? Well, maybe it's 3 and 2. Okay, let's test that. 5 times 2 of course is 10, 3 times 2 of course is 6, 3 times 2 is 6, 5 times 2 is 10, 10 plus 6, 16. So it's not this. Okay, so now we have to think more about it. So what could we change? Maybe we could swap these. No, that makes, what does that make in the middle? 15 and 4, 19, not this. Okay, maybe the 6 is a 6 and a 1. Could it be? 12 and 5, 17. Okay, so we have it now. So, I mean, it's a little bit harder. It's a little bit harder, but still, it's still just mental arithmetic. It's mental arithmetic. Because it makes you mental. Okay, next question. Last one now, the hardest one. 25 x squared minus 20x minus 12. Right, so front times front is 25, back by back. Back by back is minus 12. So one of them must be a plus and the other one must be a minus. Well, okay, let's try 5 and 5 and 6 and 2. Okay. 30 minus 10. Well, is it? Because this is positive 30 minus 10. Yeah, so there may be something wrong with the signs, right? So maybe we'll just flip the signs around, see what happens. Minus 6 and plus 2. So that's minus 30 plus 10 is minus 20. Alright, so we have it now. So there's no trick here. It's just, like I said, mental arithmetic. Just keep trying until you figure out the combination that works. If you know how to do this on your calculator, then I guess I'm fine with that, but I'd like you to try not using your calculator. At least for 10 minutes until you give up, then you can try. So there's not much in this lesson, unlike the last lesson, so I'll tell you which ones I want you to try now. Again, I think we'll say first and last. So AX, AY, AZ, AZ. 1A, 1X, 2A, 2Y, 3A, 3Z, 4A, 4Z. 8 questions. If you can try those now, please. Huh? It's just the first and the last in each one. Okay. Can I close this screen? Yeah.